So hello, it is Monday the 15th of November 2021 and this video is a demonstration of the worthiness of Disk 02, which is a Mitsubishi drive which is up for sale, and the model number is MR535. The geometry is 977 tracks and 05 surfaces. And I have it as on my catalogue as 48,650 kilobytes, so just over 48 megabytes. So the first thing you're going to hear is the disk power on. So here we go, switching on the 5 and 12 volt supplies. Okay, so that sounded like a good disk unlocking to me. We're now going to perform a test at the Krememco BIOS level, and after that test succeeded, we're going to boot Chromix and we're going to do a further full surface test with the operating system loaded. So the next thing is, the screen's going to be blank for about 2 minutes, by the way, while I get all this working, or less. Right, here we go, let's turn on the Krememco computer. Okay, Krememco computer's on, terminal is loaded, that's what you're looking at. We're going to hit enter a few times to get a prompt. It's memory test, which I'm going to abort. I'm going to run the T command to do a test. We're going to test the hard drive, it's unit 0. And if I hit enter, I'm going to do a write test as well. This has just been a read and seek test so far. Okay, so at the BIOS level everything is looking great, so we're going to boot from the A drive. So we're booting from a floppy now, not the hard drive at all, because we won't be able to test the hard drive, and so I've made a special diskette which will boot Chromix 168 all by itself from that single diskette, and from that single diskette we're going to be running the read all program, which will read the entire disk surface. I'll also first of all use the disk info program, because the disk info program will show us the geometry of the drive. Okay, so we've done a memory test for the operating system. Booting the floppy, and it's unit 0. Right, in this case it's set to auto login, so there's no password. Switching off auto pause. I'm going to set the time. It is month number 11, it is day 15, and it is 15, and it is year 121 from 1900. Time is 7:54. Okay, so we're going to do a disk info of STD31, because this STD31 represents the device that is the whole of the first physical disk on the system. So we see we've got 5 heads, and we've got 977 cylinders. In this particular case, we do have a populated alternate track table. Now this disk has been in my possession for over 10 years, It was last tested on the 26th of September 2016. It's been in climate controlled storage since then. It contains Kremenko Unix 5.2 with the XXU and XMU only, which is a very rare product. But by the end of this we're going to be reformatting that and removing that from the system. Okay, so what we're going to do first is we've done a check to find out what the characteristics of the disk are. Those characteristics are stored on track 0, and you'll notice that the partition starts at cylinder 1. So the subsystems information was just kept on track 0. And this is all operating system specific, of course. On your system, it may not need any of that. If it's not a Kremenko system, it definitely will not need any of this. So we're going to read all of STD31. This is going to read the entire surface of the disk from track 0 all the way up to the last track. So this bit's going to take quite a while. There are 977 cylinders, if you like, which is 977 tracks with 5 heads. I believe there's a 6th surface, and I think that's used for alignment, so that's not directly accessible via we can't write any data onto that, and that's a difference between the Mitsubishi drives and the Seagate drives, which had that extra surface. So they managed to cram in the same sort of space, but with only 820 tracks and 6 surfaces. Here we've got 977 tracks, or cylinders if you like, with 5 surfaces, so hence the larger number of tracks are needed. Okay, we're going to, hopefully with the power of editing, fast forward to the end of this once we've checked that the disk reads okay. Okay, we're coming to the end of the read all. As you can see, we have absolutely 0 errors at the moment. The disk was powered on for about 2 or 3 minutes before this video started. I think I would recommend before putting this disk in production, I would run a similar test to this on your operating system a few times to make sure that the disk is still as clean as it looks, and then to remap any bad tracks to alternate track table or alternate sector table. Okay, so we have read the entire drive between 0 and 4 surfaces, between 0 and 976 tracks. Everything's completely clean, which is just wonderful. I'm going to do an Init Hard now, and I'm going to remap the disk into one partition just before shipping. I'm going to shut the system down, and I will also move the heads to the innermost part of the drive. So this is Init Hard. This is the Kremenko initialization program. We've got 5 surfaces, 977 tracks. Alternate tracks we'll leave at the end is 20. That's a multiple of the number of surfaces, so effectively it's 20 tracks over the last 5 times 4 cylinders. Starting disk is going to be 1. We're going to leave cylinder 0 for systems information. Write pre-comp 300 if you need that. Initialize the tracks, no. We are going to change the partition table, yes. We're going to make it one partition of 972. Alternate track table, leave it at 972. We are going to remove these alternate tracks. Add, it's going to be no. Delete, it's going to be yes. We're going to delete 0th one. Add is going to be no, yes. 0th one. Add no, delete yes. 0th one. Add no, delete yes. It's going to be the 0th one. see where I'm going with this. Add no, delete yes, the 0th one, add no, delete yes, the 0th one, no, delete yes, it's going to be the 0th one, and finally add no, delete yes, and the 0th one. Add no, that's it. Now we are going to do a disk info of STD31. So this is before shipping. We have got a drive prepared for a Kremenko system. It's got 977 cylinders in total, of which the 1 to 972 is the first partition. The alternate track table starts at 972. There are no alternate tracks defined. The total capacity of the drive is 48650 kilobytes, and that is basically that. I'm going to do a kill -2 to shut the system down, and then I'm going to reset the Kremenko computer to get back into its BIOS effectively. Get back to the testing side of things, do a T for test, a final last low level test, which is necessary. I should explain why. You see everything is fine. Now ST00 prompt allows me to seek, so I need to translate 977 into hex. Alexa, translate 977 into hex.
977 pence is 977 £100 sterling.
Okay, that didn't work. Alexa, translate 977 into hexadecimal.
The hexadecimal form of 977 is 3D1.
3D1. So if I seek to 100 hex, that worked. Seek to 3D0, that worked. Seek to 3D1, doesn't work. So the last track that I can seek is 3D0, and the head is now positioned at 3D0. When it powers off, I believe it's going to lock onto that track, which is the innermost track, and that is going to be reserved for a landing zone, if you like. Okay, that's it, Darry. I hope you see that this disk is working absolutely fine. I've cleaned the disk, I've reformatted it into one partition, and I've shown you actually 3 times that the disk can be read and written well, and the whole disk surface has been read totally clean. Thanks for watching.